harmonic function. You are given this function v, and you are required to find function u. So, in a complex plane, z is a function of u and the v, where u is the real part and the v is the complex part. Now, in order for an equation to be harmonic, then what is called Cauchy-Riemann equation should be satisfied. And the Cauchy-Riemann, in fact, equation tell us that if you find partial derivative of u with respect to x, it should be equal to partial derivative of v with respect to y. Simultaneously, partial derivative of vu with respect to y should be equal to partial derivative of negative v with respect to x. Now, from the given function v, we are going to get partial derivative of v with respect to y. When we differentiate v with respect to y, we differentiate it by what is called quotient rule. We are going to obtain x squared plus y squared minus 2y squared divided by x squared plus y squared, everything squared. On how to differentiate the equation quotiently, you can tune on to my YouTube channel, where I have done it for us in simple method steps, and you shall be able to obtain your result in simple method steps. Now, since by Cauchy-Riemann equation, partial of u with respect to partial of x is equal to partial of v with respect to partial of y, which is equal to this from the equation above here. Now, then from there we get partial of v with respect to x. By quotient rule, we differentiate y with respect to x, it will be 0 minus. We differentiate the denominator as we own the numerator constant. So, we are going to differentiate x squared, which will give you 2x times y, which is going to give you 2xy. Then we square the denominator, which is x plus y, everything squared. Then, by Cauchy-Riemann equation, the partial of u with respect to y is equivalent to negative the partial of v with respect to x. So when you introduce negative here, when you introduce negative in this part here, it will become positive as shown here. Then, from there now, we are going to, from this equation, we shall integrate both signs. We integrate both signs, and when you integrate and differentiate u, function u, I'm going to get u. Then to integrate the right hand side, we let x squared plus y squared to be n, so that derivative of n will be equal to 2y dy. So instead of x squared plus y squared, we substitute with n power negative 1, and instead of 2x dy, we substitute 2x dy, we substitute with dn. Now, x can be taken outside the derivative, outside the integral sign, because it is constant. So by power rule, when you integrate this part here, u1, you will be left with n minus 1 because of negative 1, plus 1 is negative 2, plus 1 is negative 1. Then you divide with negative 1 to obtain negative x n power negative 1. Then from that, you substitute the value of n, which is x squared plus y squared. You obtain this, plus a constant, a function which is constant g of x. Then from this function, we get partial of u with respect to x to obtain the following to obtain x squared minus y squared g prime of x. Then by Cauchy-Riemann equation, path of u with respect to x is equal to path of v with respect to y. Equating path of u with respect to x and the path of v with respect to y, we are going to find that this part will cancel and this other one. Then you are going to be left with g prime of x is equal to 0. Then we integrate both signs. When you integrate and differentiate, you are going to be left with that function. Integral of a constant of 0, it is constant. Meaning that our u is equal to negative of x divided by x squared plus y squared plus c. So our function will be f of z, which is equal to negative x divided by x squared plus y squared plus y divided by x squared plus y squared plus constant c. So that is how you can obtain function u when you are given a function v by use of Cauchy-Riemann equation. Thanks so much for taking your time to study with me. For more learning, kindly remember to subscribe to this channel so that we may keep on learning as we continue considering this important field of maths. Bye bye, see you in the next video.